All right, let's get the ball rolling. So good morning. Today is week 2, Thursday. Okay, so we have the lab yesterday, and tomorrow we have a quiz, right? So just logistically, I want to remind everyone, the quiz is on Gradescope. It's basically in the same format as our quiz one. Okay. A little bit of look ahead next week. Next week we will on Tuesday we have regular lectures. And on Thursday, what we'll be looking at, sorry, not Thursday. On Tuesday, we will kind of get started with pictures, with the lecture stuff. And then on Wednesday, we have our midterm. The midterm next week will be cumulative from day 1 until the end of the day on Tuesday. So that's the midterm. The midterm is on Gradescope, just like the quizzes. It's open book, open notes, open Python environment. So next week there is no lab. Okay, so if you go to the syllabus, let me bring it down here. If you look at the schedule for week 3, so we will have a quiz on Friday, midterm on Wednesday, we have a PA, right? And then there's no lab this coming week because our midterm is on Wednesday, so there's no lab on Wednesday. Okay. And our PA2 is due by this Sunday. Okay. So that's kind of the idea in here. That's the logistics. And also in the lessons area, you can see we have a sample midterm. So no, more than one sample midterm. So we have spring 2020 midterm. This is on Canvas, right? I think this one has the correct answer. This is the midterm from fall 2021. This one has the solution in there. And there is also a midterm 2 in here. And then the fall 2021 midterm. I think, isn't this the same? Looks like we may have some duplicates. Fall 2021, fall 2021. I think these are the same. Let me see. Maybe it's midterm 1, midterm 2. We in the regular quarter sometimes we have 2 midterms. Yeah, I think this is midterm 1 and midterm 2. Yeah. So this is fall 2021 midterm 1. This is fall 2021 midterm 2. Let me make sure that is less confusing. So you can see them with the solutions. So use them as practice. This coming Tuesday, we'll get started with pictures, and then I will use the remainder of the lecture for QA. So for this coming Tuesday, if you have any questions about the midterms, then I'll be happy to explain. But other than that, I think that's the logistics. Any questions about midterm or logistics for this week or next?
I have a question about like the grades. I know it takes a little bit for it to appear on Canvas, but I just want to know if there's any other way I could see like how I'm doing on like the PAs or like the lab quizzes or that sorts.
I think if you go to add STEM, you can see your PA grade when you submit it. I believe you're gonna see your overall PA grades in there. We'll try to port it every week. I just instructed the tutor to do it, and hopefully you'll get it done this week. So by the end of this week, we should have the 2 labs and a PA in Canvas. But I think when you submit PA, you should be able to see your grade, if I'm not mistaken.
Where can you see that? You said when I submit the PAs, I can see the grade.
Yeah, I think so. If this is, I think is this the PA? And so you can see if right now I don't have anything, so I'm failing everything, but you can see the points, 10 points, 10 points, and that's PA1.
Yeah. I when I submitted it, I, like, was able to see the points, but it after, like, when this week started, it got erased from my ED, like, the main page. It's no longer there. So I just wanted to know if it's supposed to be there or
I think it's based on the setting. Let me check the setting. I can make them available if that's useful. I don't see that being a problem. So due date is open lesson. Okay. I think now it should appear on your add stem page. You can still see the lesson. You can view your attempts now. So that's PA1. And then for quiz, for labs, it's the same thing. Let me open up the labs.
I'm wondering if, like, because the due date's already passed, it's no longer to be showing, but I don't know if
Right.
that has to do.
That's the setup. Basically, if the due date has passed, it disappears. But I can open up the lesson even after the due dates, so you can see your submission result. So for the labs, you can see them in there too. Okay.
Okay, thank you.
And we'll part the grades to Canvas. And we should do it every week. So this week we'll definitely part week 1 grades in there. Any other questions? All right. So let me see. For today, we will be looking at memory models. Okay. Memory model is basically a way for you to understand your program. Okay. So here is, I think last time we were looking at this example, but we didn't finish it. So the first thing is we will do a little bit of practice, and then we'll look at the memory model in here. Okay. Did we do this to some? I remember we may not have, but I may be wrong. I don't think we did it last week. No, on Tuesday. I don't think we did it. I think we stopped at the coding exercise. Square root, selective square root. I think that's what we have in there. We didn't do the 2 coding exercises with word count as well as to sum. So how about we do some of the exercises from Tuesday, and then we will do the exercise for today. I think for today, I only have the 2 sum in there. And then we have some other exercises. All right, let's first look at the word count. Okay, so we have this exercise in here. Here we go. I'll send it into the chat. You all can work on this exercise here. Okay. So word count difference. So let's get started. So give me a vote once you are done with this exercise. This one is more about string functions. Okay, where if I can take 2 string parameters, we return a difference, the number of words in the 2 strings. Okay. one appeal is done. Okay, you are just basically calculating the difference between the word count here. It's like a warm up bus. Okay. Two of us are done. All right, let's, we only have 5 people voted in. Try to do the word count in here. Okay. Let's vote in. All right, I think due to time, we have to work on this together now. So we are given 2 strings, right? The first thing is you want to ignore the leading and trailing spaces in the strings. So we can use the strip function, right? So we say first string equals to first string dot strip. And then second string dot strip. Right, so this would remove the leading spaces. Now you need to figure out how many words are there. We basically want to, we are assuming, right? Each one of them only contains strings and words. So what we can do is we can use the split function. So we say words 1 equals to first string dot split. it's gonna split it based on white spaces. Words should be words 1, words 2 equals to second string. Dot split. And then we simply return the length of them, words 1 minus the length of words 2. And that should be it. So if we call this function in this way, it should give me 3, right? If I print it out. Let's try it. Typo. Let me see. Word count difference. Oh, did I strip? Okay. So let me clear it. So tell me it's 3, right? So this would remove the leading and trailing spaces, and this split would split the string based on the white space. Okay. So if you have multiple white spaces in here, it shouldn't really matter. Still 3, because it's just gonna split the entire string using one or more white spaces. When I say white space, it includes tabs, new lines, and spaces. Okay. Any questions? And all these functions that I explained in that video, one of you mentioned that the video was not available. I think there was something wrong with the transition, so the link didn't work, but now it should work. There should be this video that I recorded before, so you can watch this one, okay, to understand these functions better. Any questions about this part?
I have a question.
Uh-huh.
What if the second string is bigger than the first string?
Then it will be a negative.
Oh, so it doesn't matter if it's like the other one's bigger. So it just needs to show the difference, positive or
Yeah.
negative.
Yeah. So,
Okay.
so now this one has 4 words, this one has 3 words. If you run it, it'll just return -1. Yeah. Oh, it depends. Also depends on the question. If you say I want to know the absolute difference, then you use the absolute value. ABS, that would work too.
All right. Okay. All right. Thank you.
Any other questions? All right. Now let's look at this two-sum. Two-sum is you need loops to do this, right? So you're given the list, you want to print out all the pairs whose sum equals to a parameter t. In other words, you're given this list, this nums is a list, and t is the parameter. For example, if this is my nums array and the t is 10, I want to print out 1, 9, and 3, 7. The order of pairs don't matter. In other words, you can print out 1, 9 first or 3, 7, but you don't want to print out like 1, 9, and 9, 1. You can assume every data in this number is unique. In other words, in this list, everything is unique. So how do I do this? How do I do this? I'll give you some time. This is the link to the coding here. Let's get started. work on this one and give me a vote once you are done. To sum. Basically, you need some sort of nested looping structure to make it work. You want to know, I add up 2 elements in the list, and each for loop would give you an element in the list. One of us is done. You need to work on coding here. One of us is done. Only one of us is done. 1 more minute, then we will work on this together. And All right, so it looks like we are maybe a lot of us are confusing here. So let's try this one, right? So you have this list and you are looking for this T. This is where a for loop would give you two indexes come in handy. Okay, so how does this work? You basically would first know n equals to the length of nums, right? This is how big it is. And then for I in range of n, basically this I is an index. If you look at it, if you have this list, by saying I is here. And then we're looking at if the element at location I plus the element at location j equals to t. If that's the case, we will print it out. So j should start after I. For j in range of I plus 1 to n. In other words, the first value j would take is the value after I. And then if nums I plus nums j is the same as t. Sorry, my Java and C++ syntax popping in here. If this is t, I would simply print nums I, nums j, and that's it. So if I say to sum a list of 1, 3, 7, -1, 9 with a value of 10, I'm expecting to see 1, 9, 3, 7 Python to sum.py 1937. So this is where nested for loop would be useful when you need two locations in a single array. The other situation where it is useful is when you have the a grid with 2D grid. That's when it may become useful. Okay. Any questions about this? All right. So that's the leftover exercise from Tuesday. Okay. So now we will start the material for today. Okay. So one important thing that I want to stress is in Python, there are two kinds of data. The first kind is called basic or primitive. They're kind of easy types, like x equals to 5. Integers, they are primitive. Float, like 5.5, that's primitive. True or false, in other words, bool type is simple type. So we're looking at int, float, bool, string. They are the basic types. But there are also other more complicated types, like a list. So lists, they are objects. In other words, they're complicated collection of data. So it's important that you know if you say list 1 equals to 1, 2, 3, 4, list 2 equals to 5, 6, 7, 8, inside your head, you have a clear understanding of what is going on here. This would create an object. So 1, 2, 3, 4, this part is an object. What list 1 contains is the address of this object. This object is stored in a special location called the heap. And this list is in general stored in this special region called the stack. Okay. So objects are in the heap. We call this list 1 is a reference. So what does reference store? reference variables, they store the address of objects, of where they are. Okay. So list1 holds the address of this object. Why do we use an arrow? Normally, the address is just like a big number. That indicates the address of this object. And that number in general doesn't make too much sense to us. So we just use the arrow to say, okay, this address would allow you to have access to this object. List2 is pointing to another object. If you have this kind of statement, list1 equals to list2, this might be the most confusing thing for most of us. In here, if I say list1 equals to list2, you are not changing the objects. You are changing the references. You are basically giving the value of list2 to list1. If the value of list2 is the address of this object, then list1 would hold the address of this object. So in other words, list1 and list2, they will be pointing to the same object in here. And that's it. So what's going to happen to this object that no one is referring to it? This object will be recycled. So you don't need it anymore. Okay. Are there any questions about this?
What is stack again?
A stack is a region in the memory. Let me give you a visualization in here. Okay. And yeah, do I have memory model? Yeah. So let me first give you an analogy. So if you think about stack, and so you may have your Python code, right? So this is your code, .py file. And when you say Python, your .py file, your code starts to run. The machine would basically says, I need to support the execution of the program. So your program is assigned with some memory, and all these computers have their memory. Let me show you. So let's see, system information. Yeah, in here, if you look at it, this is the system information on my computer. Where is the memory? So this is the physical memory. Okay, that's the amount of memory I have on my computer. And when I run any code, like Python code, Java code, or when I open up Microsoft Word or browser or PowerPoint, whatever, certain amount of memory is allocated for me. And inside this RAM here, there are two regions in the RAM that supports the execution of the program. One is called the stack, the other is called the heap. Stack is used to support different functions. So there are small rooms that got created and destroyed in the stack region. Heap is it's like a wild west. It's big, and whenever you have objects, the object stays in the heap. And all these objects are manipulated using the reference variables that we have. So that's in general how you can visualize it. So the RAM supports the execution of your code. So there are two entities. When you run your code, you need the instructions from the code. You also need the RAM to facilitate the storage, like the variables and objects. Analogy is like your Python code is the Amazon.com website. In order for me to order something, I interact with the website, but at the back end, there's a warehouse somewhere in the world that would prepare the package. So you need both of them to be working well in order for Amazon to work well, right? So that's how it goes. Any questions about this? How do I visualize this? Number one, you should have a clear memory model. When I say memory model is what is going on in the RAM as you run your code. The other, so the stack is like stock. No, it's stack, S-T-A-C-K. why is it called stack? Because all these small rooms, they're like stacks of plates. When they are created, the new one would stay on top of the old ones. When they get destroyed, you destroy the one on the top, and then you go back to the one underneath it. So it's just like if you go to a buffet, where there aren't too many buffets anymore after the pandemic. But what happens is you grab the top plate, right, and then the next person would grab the next plate. So that's why it's called a stack. It mimics that behavior. Yeah. Yeah, you can think, well, stock also keep things. So everything in the memory is used to store things. Right. So I would say memory is like it's like just like rooms that would support the execution. Okay. Any questions about this? Let's look at one example in here. Okay, so the example is this one. I have this code, I have a function, okay, and then I have a list, then I call this clear list. So what is going on in here? There are several principles. Did I list the principle? No, I didn't list the principle here, but I will try to write it down. I think in one of the slides, I did list all the principles. I didn't list it in here. So there is a software called, there's a website called pythontutor.com. And in our exams, in our quiz, you can use this website. That's fine. Okay, it basically helps you visualize the program. And also you can use it as a debugger. So I have a link that links directly here. So pythontutor.com. In fact, this one is made by one of our own faculty. His name is Philip Squaw. So let me show you. I think he's with the cognitive science department. Pythontutor.com. It didn't have credit in here. We're not responsible for the ads. Yeah, I don't think it has the credit to say who made this thing, but it's by Philip Guo, who came to UCSD I think, five years ago. So it's a very useful tool. What you can do is you go here and then enter the Python code. I think I already entered it, and here's the link. So this is the code. And it will help you to run the code step by step. Okay, but let's do it. So this is the first line. When Python look at a function, right? This is a function. It doesn't really run the function body. It will just say, okay, I have a function called clear list. It takes one thing. That's about it. It just remembers there's such a function. As well, what the function does, it really doesn't make any difference to Python. So Python would only execute the function or check the function when the function is being used. In fact, it's a pretty bad thing, right? Just for example, you say a function is like the braking system of a car. And what Python does is to say, I'm not going to check the braking system until you are driving 70 miles per hour on the highway. That's when I will check if the braking system works or not. It's pretty bad, right? But that's what Python is designed. So when I run this code, if you click on next, it just remembers, okay, there's this clear list, and in fact, there's this function. Clear list, the function name, in fact, is also a reference. And you see there's this thing, there's frames, there's object. This is more like the stack region. This is like the heap region. Okay. And you can see there's this thing called global frame. What is a global frame? global frame is a region in the stack where all the things you created outside functions would be put into. So there's this function called clear list. It's in the global frame. And then I'm about to run this line. The red arrow tells me this is the line that I'm about to run. Okay, so if I click on next, you see nums is created outside any function. So nums is pointing to this list. This list is an object. So element 0, element 1, element 2. And then I'm running this clear list function. So I'm calling this clear list function. And what will happen is I will jump over there, run the body of the function. And this is where you see the global frame is no longer blue. If you go back, this is global frame. Now a new frame is created. This frame is for the clear list. This LST is the parameter of this function. It would obtain the value of the argument. The argument is nums. Nums holds the address of this object. So that address is given to list. So now list is holding the same address as this object. In other words, the global frame in nums and the LST in clear list, they're referring to the same object. Now I'm generating the index. So now there is an IDX. Initially it is 0, right? This index would go from 0, 1, 2. So list index minus 1. 0 minus 1 is -1, which is this last element has an index of -1. So that one is changed into 0. The loop would run again. Now index is 1. Location 1 minus 1 is location 0. So this part would change into 0. Run one more time. Now index is 2. 2 minus 1 is this thing. So now it's 0. So I basically wipe clean this entire list. And then I'm done. So I'm ready to return from the function. The return type is none. Once a function is done, its stack frame is destroyed. In other words, everything in here is gone. We will go back to the caller. In the code, we'll also go back to the caller's frame in here. So you see the code would go here, and then we only have this frame. Now the code is done. So this is kind of how the code runs. So what Python tutor allows you to do is to run your code one step at a time. Okay, 1 step, 2 step, 3 step, and you can look at the values of your variables, the values of your object, and see how it goes. There are limitations of Python tutor. For example, when we are writing code for like pictures or CSV files, it doesn't work in here. Okay. But for like a regular code, you can just step through the code and see what's going on. Are there any questions?
Yeah, I have a question. So when it goes to index 0, and then you -1, isn't that like index -1? So does it just ignore it?
Well, index -1 because Python allows negative index. So the last one is -1, -2, -3. So you're looking at this one.
Oh, okay. All right.
Yeah. Any other questions? So this is the idea of Python tutor. So feel free to use it. So let me kind of summarize this a little bit, and then we're gonna take a small break. So number one, anything that is not part of function, they would, like the variables you create, they would stay in the global frame. There's only one global frame out of the entire Python code in here. And then when you call function, you go to execute the body of the function, and the stack frame of the function is created to support the execution of that function. Once this function is done, the supporting stack frame also got destroyed. It's just like when you call function, you're like creating a clone of that function. If you imagine the function is human, then that human would have its own head, its own brain. So the brain can kind of execute instructions, can support storage of the variables, right? And once the function is done, that clone human is destroyed, which is crazy, but that's kind of how you can think about it, like in the Matrix movie, right? So, and then if the function is called again, a brand new clone is created with the supporting brain. That supporting brain is like the stack frame, right? So these functions, they do not share the same brain. Each of them have their own brain, so their stack frames are totally independent from each other. But if their memory stack frame has access to the object, they may refer to the same object because there is only one heap region. So there may be multiple stacks, but there is only one heap. It's not like every function would have their own heap region. No, they all share the same heap region. Okay. Any questions? All right, then I think this is our introduction to memory model, and then we will come back and vote on this one once we finish the break. Okay, so let's take a break, come back at 12 o'clock, and then we will continue. Okay. All right, everyone. Let's get the ball rolling for the second session today. Okay, so we talked about memory model, right, in the first 15 minutes. Now let's try to practice it. So we have a function in here. I have a list. I call the function by passing the list to the function, and then I print out the name. What would you say the list will be now? All right, so let's vote in, please. Vote in. All right, let's look at the votes. A majority of us voted for A. It's going to change the list, right? So you can see name is pointing to this object, TYC, right? And now I'm calling this update function. So this is the global frame. And now we have the update frame. This is the brain of update, it has a name. And this name would contain the same address as the name inside global frame. And we say name 0 equals to Shannon. So this one changing to S. This one is S. So Shannon, S, Chow. So it should be A. A is the right answer in here. Okay. Any questions about this? All right. Next one. Okay. So the methods in Python deals with objects. So in objects, they have methods. And this one is just a quick practice of the methods for strings, right? So you have a list or you have a string, like for example, you have a list in here. I do a bunch of append. What do you think the methods will be in here? So when you have objects, in general, the objects can do things for you. And objects do this via function calls. Okay, that's what it does. Let's do a quick vote. Then we'll go back to memory model. Okay. Vote in. All right. So a majority of us said B. Let's check, right? So append function on lists will give you a 2. So it's just going to append to add the new thing to the end of the list. You see a 2. Now 2 double asterisk 2, this means power. So it's 2 to the power of 2, which is 4. And the 8, this is 2 to the power of 4, which is 16. So it's going to be B. Okay. So these are not, so Python doesn't store mathematical expressions. You just do the math and save the result. Okay. Are there any questions? All right, how about this one? This one is the methods from strings. What would this one do? We call split. And we're splitting based on semicolons in here. So every one or more semicolons would be treated as a separator to separate different fields. Now, how many elements do I have? Split would return a list. We are basically looking at how many elements are in this list. All right, so most of us voted for B. We are saying 4. Let's check, right? So if you look at the separators, this is the separator, this is a separator, this is a separator, this is a separator. So there are 4 of them. That's unfortunately incorrect, right? So if you think about, if I say A comma B, this would say there are 2 things, right? Because each separator would create 2 things. There's just this kind of bad separator in the end. So what's going to happen is there will be 5 things. There'll be 5 things. So the 5 things are A, B, C, D as strings, right? They're all strings. And then there's an empty string. Because if you count there are 4 separators, then that would give me 5 things. That will give me 5 things. Okay. So that is the idea. And so why is it like this? Because sometimes you do have empty data in a certain field. So it doesn't automatically say, oh, if it's empty, ignore it. It doesn't. Okay. Are there any questions about this? All right. So let's move on. How about this one? We're splitting based on this emoji in here. What will be the result if you have words in here? This one shouldn't be bad. What is the result in here? All right, so the answer is A. I think we are doing good. So basically, this part is the data. This part is the data. This part is the data. Right? So 3 data points. It's just allows you to split the data, and a lot of times you may see this kind of expression. Normally, people don't use colon dash, but sometimes people say this is the separator. So a slash, maybe a separator, it becomes very handy. How about this one? If I have a string, I say join, and I'm joining these things. What would you say the answer is? These are just basic functions that comes from list or string objects. String are not objects. Okay, in this class, we don't treat strings as object, but list definitely is their objects. Okay. All right, so we'll stop the vote. Okay. The answer in here is if you have these things and we're using add to concatenate them, there's 1 plus 2 plus 3. Right, so if I have a list, you say, let me convert the list into a string, and I want to use this thing as a separator. So that's what happens. You end up with a string like this. It's not 1, 2, 3. Okay. If you have an empty string in here, I say dot join, then you're gonna see 1, 2, 3. But this one will be used to connect the individual elements in the list. Okay. Are there any questions? All right, I think this is the last exercise about basic methods. So we have these things. This one is a little bit crazy. Okay, so what does this one do in here? A few statements. In the end, we want to know what is new message. So Take your time with this. There is one question. I'll answer that. But vote on this one first. There's a question about the previous problem. Yeah. All right. Let's see. We disagree with each other a lot on this one. So interesting. Let's end the poll. It looks like if you look at it, we disagree with each other a lot on this one, right? So what does it do? So we have a message. We split, then you end up with the list. It's live as a string, love as a string, love as a string. And we have a list equals to this one. And if you look at this part, we're going from the last element all the way to the beginning, but not including 0 because the step size is -1. So we're saying the length of the words is 3. We're starting from location 2, going backward, will append the word to list. So this LST, in the first round, LST, this list would have LA in there, love. And then the next one is love. It doesn't go all the way to the beginning because for range, it doesn't include the ending point. And then we say join everything here with comma. So it should be love, comma, love. So it should be A. The answer is A. Any questions about this part?
Can you just re-explain line 4, where it's like for I in a range length word, like how you went about it when you said like, oh, we skip 0 because of -1? I just got lost there.
So length of words is 3. 3 minus 1 is 2. So 2, 0, -1. We talk about range on Tuesday. So we say this is the start, this is the end point, and this is the step size. So we start with 2. The next value is 1. The next value is 0, but we don't include 0. So it only the I value would only be 2 and 1. So when I is 2, we are appending love to list. When I is 1, we are appending love to it. And it doesn't include 0 because the ending point is 0 in here. Range doesn't include the ending point. So that's why lists only have 2 things. When you call join, it's just these 2 words joined together. Any other questions? So another question that was raised before is one of you said, I just said Python doesn't return math equations. I never said Python would not return math equations. I said Python never store math equations. Because if you say x equals to 2 to the power of 3, what is inside x? X doesn't equal to this mathematical expression. X just equals to 8. That's what I mean in here. And this is not a mathematical equation. This is a string. It's not 1 plus 2 plus 3. This is a string, 1 plus 2 plus 3. If I say x equals to quote 2 asterisk 3, then we're looking at x equals to 2 asterisk 3. Because that whole thing is a string. In other words, when you try to do math, Python will just do the math and store the result. But if it's a string, string can be anything. It can be a mathematical expression, it can be a name, can be anything. So Python would literally store that string in there. Okay. Any other questions? Okay. So here are summaries. I think we may have even a kind of another summary later on. So this one is a useful slide for you to kind of refer to when you think about the idea. So stack frames is like the brain for the clones. So every time a function is invoked, in other words, every time a clone is created, this invocation gets a new frame, gets a new brain. That brain belongs to that human clone. The parameters also exist in the parameters of that function is in the frame. All the variables you created for that function is in the frame. And when Python is looking for a certain variable, like what is the value of this variable, it will look inside its own frame first. If it can't find it, then it will refer to the global frame. In other words, it will try to look for a local variable. If it doesn't exist in its local frame, then we will have to do it. We'll have to find it in the global frame. For the global frame, there is only one global frame. All the functions have access to this single global frame. Okay. So when the variable name is used, it will look inside its own frame first. Otherwise, it will try to go to the global frame. I didn't know I can even move this thing. So the global frame is only used when a function can't find it inside its own frame. Okay. And that's it. So this would the ultimate design principle here is different function calls don't interfere with each other while allowing a limited way for the functions to share something. That's basically what it is. Any questions about the idea of how do I get rid of this? Okay, there it is. Any questions about the basic idea of a stack frame? Let's look at this one. Okay, so application of the stack frame, we have a function, and then we call it, then we call it again. What happens when this function is called? Let's, can you draw the memory model by hand, by yourself? Let's work on this one. All right, 3 of us are done. Okay. I'll give you 1 more minute. Solve it together. All right. Let's work on this together. What happens? First thing, you have a global frame, right? This is a global frame. Every variable that you create would be inside the global frame if that variable is not created in the function. The first thing we do is the first line that is not a function. So this is full 4. So we have a full 4 in here with num equals to 4. Right, this is the stack frame. This is like the brain of the clone. So if num is bigger than 0, you return 1. So basically, this function would simply go back with the value of 1, and then this frame is destroyed. And then we say val equals to 7. This val is in the global frame. And then we say full val. In other words, a brand new frame is created for full. Now this num has a value of 7. If num is bigger than 0, you return 1, and then this function would have a 1 as a return value, although we just throw them away. So if you look at it, there are 3 stack frames that are created. The first one is the global one, is always there. The first call would create the first frame. The second call would create the second frame. Okay. Any questions?
And the global frame ever get destroyed?
Well, when your Python code finishes execution, then
Okay,
it's destroyed. There's one question: why is val in the global frame? Because this val is created outside any function, right? That's a function. And this val is not created in any function. So this val exists in the global frame. Any other questions? All right, so a few exercise. What will happen if I run this code? Vote in. What will be created? All right, so a lot of us said C. That looks okay, right? That's good. So why is this X is not defined? Because this X would be created in the stack frame of set X. And when Python even run this code, it doesn't even run this thing, right? It just prints out X, and we're saying, well, what is X? It doesn't even run this code, doesn't run this function. So that's why X is undefined. Okay. the body of a function is not executed until the function is called. And even if I call this function in here, like what's going to happen? I wouldn't tell you the answer, but in here, if I call set x first and then print x, what would you say will happen? All right, stop the vote. C is still the right answer. Okay, I think some of us voted for A. Even if you run this function, remember this x is created inside the stack frame of this set x. Once the function call is over, that frame doesn't even exist anymore. And you say print out x, and this print x, since it's outside any function, you can only print this x if this x is in the global frame. If it's not in the global frame, there's no way you can access this x. I hope this makes sense. Any questions?
If there wasn't a print x and you just called the function, then would just nothing get printed out?
Yep. So if you just call the function, then there won't be any error, but nothing will be printed out. Any other questions? And the other thing is, do not confuse print with return. Print means display something to the console. Return means you're passing data around between the functions. So those are two different things. Okay. It's just like return statements are like if you, I don't know, if you're broadcasting a football game. So there are different people doing different things to broadcast, but those are the return, right? Those people are talking to each other. But the print statement is like the score of the game. You print it, you put it onto the TV screen. That's print. The print and the return are totally two different mechanisms. So do not confuse them. Okay. How about this one? Count function, x equals 1, x plus equals 1, print x. What will be printed out, or if there's going to be an error? All right, so a majority of us voted for B. That is correct. So it's going to be 2, 2, 2. Why is it 2, 2, 2? It's because every time you call count, this x is initialized to be 1 and then change it to 2. You print the x, and then the entire frame that contains this x is destroyed. You call count again, a brand new frame is created, you recreated x in that frame, you increase that x by 1, you print out that x. So basically the stack frame got destroyed every time you finish a function call. There's no memory. Well, I shouldn't say there, but there's no lasting memory of what happened to a variable in the stack frame. Once that stack frame is destroyed, you start with a new frame every time you call function. Any questions? All right. So these are the key points of stack frames. Okay. So let me go through them, and if any of these statements is confusing or is unclear, I'll be happy to explain more. Okay. Number one, Python doesn't evaluate the function until it is called. So Python just look at the function, doesn't look into the body of the function, just move on to the next thing. The first line to execute in the Python code is the first statement that isn't part of any functions. A function would return when the last statement of the function is executed or when the return statement is executed. A function always goes back to its caller. It doesn't go back to the global frame by default. It goes back to where it was triggered. A function stack frame is created when the function is called, and the stack frame is destroyed when the function returns to its caller. A function can only access variables in its own frame or variables in the global frame. Local variables take precedence compared with the global variables. It means if you are trying to use a variable, Python would look into the stack frame that owns that variable potentially first. Like if you're in a function, you're trying to use a variable, it's going to use that local variable first. If you can't find it, then it's going to go to the global frame and look for that variable. If you can't find in the global either, then you're going to see an error. Okay. Any questions?
Can you explain number 5? Like how would it? Well, what's an example of when it would return to like its caller?
In here, for example, this variable, this function call, once it's done, it's going to come back to the caller in here. So this is a call. You take a detour to the body of the function, then come back and resume the execution after the function call. So that's what it is. Maybe a more extreme example. Let's see. Let me, where I have a example here. Hold on. To Thursday. Let's look at this example, right? I thought we just did this one. Nonetheless, right? So if, for example, I say define who, I would simply print who, and then I in here I call bar. So there's another function called bar, and this function just print out bar, right? So if I call foo right now, so what would happen? You're gonna jump over there and you can print out foo, and then you're gonna call bar. Let's for example, I have another print. So if I call foo, I'm jumping over here, print out foo first. And then I call bar. In other words, I'll jump over to this function. I finish printing out this thing. And now where do I go back to? I go back to my caller. I will go back to where foo was. And then I would call done. I print out done. Then I'm done with the entire foo function. So this is where once a function is done, it doesn't go back to main. It goes back to where the function was triggered. And this is the part where bar was triggered. Once bar is done, it's going to go back to the next line that is after that function call. Okay, that's like statement 5. Any other questions? All right. So now let's look at this one, right? When you look at, so the last part for today, I think, is debugging and some exercises. Okay. So when your code has a bug, there are 3 kinds of errors. When your code has a bug, the first kind is called syntax errors. These are the easiest ones. So in other words, you say, I forgot a colon in here, or I forgot my tabulation. Python would basically say, oh, there's something wrong with your syntax. It's going to give you the error message. So these syntax errors are the easiest to fix because your code can't run because of these syntax errors. And in the beginning, we make a lot of syntax errors, but over time, the number of syntax errors we make will be getting smaller and smaller. In other words, we don't make as many mistakes as we have in here. The second kind is my code runs, but it crashes at a certain point. For example, I have this code. I say, I'm printing out 5 divided by I. For every element in here, I would divide them by 5. So it's 5 divided by 1, 5 divided by 2, and then 5 divided by 0. This is called backtrace. What backtrace really does is to show you where the problem has happened. So it's in this test.py in line number 3 in this part. And it's basically you go to this file test.py in line number 3, you see this line, and the error message is division by 0. In other words, it tells you something has happened, and the error is you are dividing by 0. So you want to go back to your code and hey, why do I have a divide by 0? And then you realize maybe you should check if I is 0 or not before you do the division. That is the 0 division error in here. This is the runtime error. So your code runs, but it crashes. The last kind is the worst kind. It's called logical error. Okay. For logical error, this is the code in here. For example, I'm trying to calculate the average of everything here. What I'm doing is I'm adding up everything in the list, and I divide it by the length of the list. It prints out 5.0. Well, give me a value. Is this right? Unfortunately, the value, the answer is now 5.0 of the average of these elements. It should be 4 dot something. Why? Because I initialized my average to be a wrong value. My average should start with 0 instead of 1. But you may not have seen this. You may not have seen this before. Right? So this is based on your logic implementation. So you say, this is how I do it. And this whole thing would make sense to you if you made that mistake. The whole thing would make sense to you. So how do I basically find out where the problem is? Your code didn't crash. It runs, but it just gives you the wrong answer. So this is probably the worst kind of error to fix. And keep in mind, okay, when your code crashes or when it gives you the wrong value, you have to learn how to debug. But debug is a very frustrating process. Okay. Because in your mind, your code would make sense to you, even if it's buggy. Because every time I see a student who come in for help with the assignment, they always say the code makes sense and I'm very sure the code would make sense to you. If the code doesn't even make sense to you, then we have a bigger problem, right? So I wrote the code, it must have made sense to me. Otherwise, I wouldn't have written it in that way. But it doesn't mean it's correct. Something that makes sense to me doesn't mean that that thing is right, right? So you want to kind of know a little bit of debugging skills. The first rule is trace your program. Run it step by step. Try to print out the values of the variables in your code. And then you say, well, you can use print statements or you can use Python tutor to step through it. Either way is fine. And the most important thing is you look at the values of the variables. This is extremely useful because these variables, they're basically the memory, right? So you say, I'm having a bunch of instructions, but the supporting memory, which is the variables and objects, if their values are wrong, it must mean that your instructions are wrong because these values, they only follow the instructions, right? So if the values of the variables are wrong, then your code is wrong. And that's where you can pinpoint the problem where code might be wrong, okay? So if the values of the variables are wrong, that's when you would have found a bug. And sometimes you may have multiple bugs. So it's not just say, I found a bug, I'm done. You may have multiple bugs. You go to isolate those bugs, and this is kind of where you have to systematically debug your code. If your code needs to read in something from the user, you want to check, did they even read in the things properly? Right? If the thing was not read in properly, then I got to look at the reading part, right? If it's read in properly, then I say, well, did I make a mistake in my calculation? You check the calculation part. Calculation also looks good. Maybe you print out the data incorrectly, right? So then you kind of examine the output part. So in general, you should follow these steps. You don't want to check the output part first, right? So that's how I would systematically debug. Python tutor can be useful, okay? Any questions about these basic principles? All right, so here is a piece of code. Now, given the list, I'm looking for the minimum value. I print out the minimum value once I found it. So there is a bug in this code. Well, I think there may be multiple bugs in this code. Can you fix it? Can you fix it? Okay. There is a question about the logical error. Logical error, basically calculation errors. So you are supposed to do something that you did it incorrectly because when you try to add up a bunch of things, that variable to store the total should start with 0 instead of starting with 1. That's a mistake, and that's why there is a logical error or calculation error. So let's try to look for the bugs in here. Where are the bugs? You can, let me copy in this code. It's hard for me to paste it because I think it's gonna mess up the indentation. I can try to make it work. All right, so this is the code. You can use Python tutor to debug it, or you can run it to try to print out the values. And give me a vote once you say, I have located all the errors. This is a debugging exercise. Okay. I put the code in the chat. Maybe do I have something in the add stem. Maybe I already have it. Oh yeah, it's already in here. So you can also use the add stem code challenge in there. Okay, so try to debug this one. Let's. I think it's also break time. Okay, so if you have time during the break, you can take a look at it. But let's take a break and we'll come back and I'll give you some time, maybe a couple minutes to debug this code. Then we'll do some coding exercises in the third section. Okay. Let's take a break. Come back 1 o'clock. Okay, come back at 1. All right, so let's get ready to come back. Okay. Then let's debug this code together. Okay. We'll start in a minute. All right, so let's get started here, right? The first thing is, well, are there any obvious syntax errors? Doesn't look like it. Columns, the indentations, everything looks good. Now let's run it. Java, Python, test.py. It says the minimum is -1. Well, that's incorrect. So how do I fix it? This one looks okay, right? Just a list. There's really nothing in there. Then we call find min, and we'll print out the return value. Probably something is happening here. Result equals -1. For every value in here, if result is less than the value, value equals to result. So the idea of finding the minimum is if I see something smaller than me, I have to remember it. But this one looks like if I see something bigger than me, and I'm changing the list, I'm changing this value instead of remembering it. So probably this is what it means. Result is bigger than value. In other words, if I see something smaller than me, as a result equals to well. Maybe it's just this if, right? You test it again. Oh, no, the minimum is -2. That looks good. But it doesn't mean this code is perfect now, right? So we were able to fix one logical error. There's another logical error. Did anyone see any other logical errors in here? You can use the chat or you can unmute. What is the issue in here? No one can see the other logical errors. The logical errors can be tricky, right? So what if my array is like this is 2, 1, 3, 2, 9, 1, 3, 9 to 10. If I run the code, I'm expecting a 1, but it will tell me -1. The -1 value isn't universal. In other words, this is not guaranteed. When you want your result to store the minimum value, you want your result to be to start big. So you may say, well, what if I change this into 1? Well, then it's gonna solve this problem, and it will also solve this problem, right? So if I say, okay, if my result start with 1, it is give me -2. If I change this into +2, it's gonna give me this one. It's gonna give me 1. So everything looks good. But what if this is 11? And if you run it, let me clear it. And if I run it, it's gonna tell me 1. The minimum of this thing is 1. And as you can see, it's not good. Right? So it looks like I want to start with something big. How about 1,000 or 10,000? Then it's gonna work. So if you have something you want to store the minimum, you want this value to start with something big. But what if all the values in here are 1 million? Then the code would give me a wrong answer. So there's no way that I can predict how big or how small the value is. So the easiest part would be if I say, okay, if result is num 0, this is the best way. So you initialize your result when you're looking for minimum maximum to be the first value in the list. It can be any value in the list, but there's always a first value, right? Technically. So if your list only has one thing, there is a first value. So this would solve all the problems that we have seen before. But would this also be perfect? My code is not perfect yet. What if this list I gave you is empty? And I run it, my code would crash. So this brings back the importance of test cases. You must design test cases. It will be hard for you to say, I finished writing the code, now let me test it. I just design a single test, looks good, move on, right? So it's hard. You got to design your test cases beforehand. So if this is empty, I'm in trouble. So I want to basically say, if the length of nums is 0, what should I return? I should just return none, right? You have no minimum. Other than that, I initialize my result and do this. That's how you should try to debug your code. It's about what if I can't see it, right? We are just looking at it. So if you look at the code in here, I can copy it into Python tutor. I'll go to pythontutor.com. And say, okay, here's the Python code. Now I'm ready to run my code. Visualize execution. You run your code step by step and observe the memory model. So first thing, I have a global frame where I have a find main function, and then just pay attention to the red arrow, right? So I created a value with these things, looks good. And then I'm calling this find min. So I'm stepping in there. There is a find min function, nums is pointing over there. Result equals to -1. I want to go through here. Val initially is 1, so that looks good. If result is less than val, this is when you would see there may be a problem, right? If result is less than val, if this thing is less than val, so which is true in here, right? So I'm gonna change val into result. I'm gonna change this thing into -1. What's the point? What's the point, right? I want my result to store the smallest value I've seen so far, but it doesn't really hurt anything here. And then you say, okay, now result is 3, and that's the result. Change the result into change val into -1. So not good. Now val is 9. I change val into -1, and now I see a -2. I don't do anything. And then I see a 10, I change val into -10. It looks like there's something that is not working here. You may want to change that. So you say, okay, let me edit my code. Where's edit this code? Maybe you should say I have result equals to val. And then visualize the execution again. And you will see that this, now it changed result into 1. Now it changed result into 3, and then 9, 10. So it looks like result is the maximum now. Result is not the minimum. And you may realize, okay, there's something wrong in here. The direction may be incorrect. And then you go back and edit this code and step through it. So you can step through the code and see where the problem might be. So that's why I say Python tutor may be a good tool for you to debug. You can also use print statements to say, okay, at this time, the value of this variable is something, and examine the state of the memory as you execute your code in here. Any questions about how to debug your code? All right, so let's move on. We have a few coding exercises. Okay, sum 6, 7. Do I already have the solution in here? Maybe I already have the solution in there. Let me edit the slides. Oh, I already have this in here. Sum 6, 7. Okay. I shouldn't have written the code in there. Let's try to practice this. Okay, if you already see the code, you can delete it just to practice. Okay. So return the sum of the numbers in the array, except ignoring sections of 6 and 7. So if you have a 6, it is guaranteed that it is followed by at least one 7. So you can skip everything between the 6 and 7, including the 6 and 7. If there's no 6, then you should add up just everything here. So in this example, you're gonna ignore this part. So it's 1 plus 1 plus 2, you get 4. In here, you're gonna ignore this part. It's 1 plus 2 plus 2, you get 5. And all these exercises come from this website called codingbat.com. So there's this website called codingbat.com. So this is kind of where you can practice these exercises and do it in here, like logic 2, is a lucky sum. You can write your code in here and then it will grade your code. So sum 6, 7. Okay, I'll give you some time. Can you do this yourself? Okay, if you're done with it, give me a vote. You want to skip the region between 6 and 7. And if, for example, if there is another 6, like if there's something like this, 6, 7, 7, like 1, you should only skip this part. The second 7 is good. You should add it up. So this one should give you 8. You shouldn't skip all the 7s. One of you is done. If you're done, move on to the next exercise. So if you are done, once more than 5 of us are done, we will work on this one. You may want to start with some test cases. Okay. Put in these tests. Only 2 of us are done so far. Some 6, 7. Four. Let's see if I got 4. And then looks like I can use some more tests, right? These are not perfect. So if it's empty, I'm expecting a 0. Do I get a 0? If I pass in 1, 6, 7, 7, 2, I'm expecting a 10. Do I get a 10? Six, 7, 7, 2. If I just have 1, 7, 7, I'm expecting a 15. Do I get a 15? Right, so you just have to design the test and make sure that your code is tested thoroughly. And these things should be done before you even start the code. Okay. And it's gonna help you to think carefully about the process of solving the problem. All right. Due to time, let's work on this together, right? So I can simply return 0 right now and run the code. It should Python code.py, right? So it's gonna fail all of them as expected. We close this thing, right? So that's what we have as of now. Now let's just run this. Let's try to detect 6 and 7, right? So the idea is this. So if I see a 6, and I'm gonna basically skip all the numbers until I see a 7. And that's when I'm out. That's when I'm out. So you should start to think about, I'm in the mode where I'm skipping, or I'm in the mode I'm adding. So you can have a bool. Bool, you say skip equals to false. I'm not gonna skip as of now. Then for every element, well, the thing is, we want the result to be 0, right? So that's the sum. And for every element in nums, and I want to check if E is the same as 6, if I see a 6, if this element is 6, I have to skip. I'm getting into the skip mode. If I see a 7, and I would say, oh, skip equals to false, you know? And I would say, okay, if I don't skip, if skip equals to false, I will add E to my total. As a result, plus equals to E. And in the end, I'll just return E. Return result. And that's it, right? That's the idea. So will this work? I don't know. Maybe, maybe not. But logically, it looks okay, right? Definitely, this would make sense to you. Let's run it, right? So we have a pretty good testing suite in here. Okay, if I see a 5, I got a 5. Ooh, this one is wrong. This one is wrong. This one is right. This one is, so I'm failing part of it. Right, so let's look at if these test cases have anything in common. So in here, I'm expecting a 5. I got a 12. I'm adding this 7 additionally. In here, if I see a 6 and a 7, I'm expecting a 4. I got 11. It looks like I added this 7 by accident. In here, I got 17. So again, I added this 7 that I'm not supposed to add. Now, where's the problem? I'm adding a 7 that I'm not supposed to add. And this is the part that I add. In other words, if I see a 7, I'm out of this mode, but I'm adding this 7 too, because once I set this thing to be false, I'm adding it. Maybe I should try to avoid this part by moving this condition over here. If it's 6, I say, okay, I'm gonna skip. If I didn't skip, I will add it. If it's 7, skip will be false. So at least if I see a 7, the first closing 7, I would not add that 7 again, because I added this thing before. Maybe it will work, right? So you run it, say, okay, 5, 5, 5, 5. So look at everything is good now. Just by switching the order of these statements. There are other ways to solving the problem. And so if it's, let me see, am I missing anything? If there's a 6, I'm gonna skip. If I see a 7, I set skip to be false. If I have multiple 7s, which I think I have in here, it did get what it's supposed to do. Okay, so it works. Any questions about this exercise? So it basically shows you to use a flag to indicate the state and the order. Like sometimes you say, if you use else if, your code would work. If you don't use else, if you use a bunch of ifs, your code won't work. So, and vice versa. It's all about logic. I don't expect all 3 of them to happen at the same time. Right? So that's what I have in here. And in fact, to be more precise, I probably want to say and skip equals to true. I said to be false, but I don't think it would matter in here. So when I see a 7 and I'm in the skipping mode, I say you don't skip anymore. Questions? Next exercise, counting code. I may also have, okay. So this one is the coding challenge in here. I would say this: return the number of times the string code appears anywhere in here. We will accept any letter for D, so cope, and we, they all count. In other words, this D can be anything. So if you look at this one, code occurred once, code occurred twice, code occurred 3 times, because codes and cope, they are counted as code. So get started in here, okay? If you are done, give me a vote, and then we probably will call it a day today. This is XYZ. Okay, this one will work. Work on this exercise. Vote in once you are done with this problem. You have to think about neighbors, right? So it's like string processing. Remember, we're looking for AAA in a string, and in here it's the same thing. Didn't see anyone voted in yet. This one is a little bit crazy, is it? print, so define count code takes a word. I just return 0 as the step. Right. Due to time, let's finish this up together. Okay. So this one is something that we should be fairly comfortable with. We say n equals the length of this word, and we just need to check, right? For I in range of n, right? So we need to check if word I is the same as C, if I see letter C, and word I plus 1 is O. And well, we don't care about the third character, it can be anything. And the fourth character, which is word I plus 3, is the same as E. If this is the case, I have a counter plus plus. Count plus equals 1. Right? So I set my count to be 0. And then I would simply return count. Right? So I have I was only able to put in 1 test cases, but we'll see if we pass this one. Passing this one would be a good starting point. Python exercise.py. I passing a 1, I expect a 1. It looks okay, right? But as you can imagine, there is a problem. I'm surprised the code didn't fail. It didn't fail. It looks like, okay, this one, okay, I know why it didn't fail. Okay, no, I'm perfect here. How about if we test your code like this? I have a C, O, D. COD, COD. If I change the BB into COD, and I'm still expecting a 1, right? And my code is guaranteed to crash at this time. I'm in trouble. So this is index out of bound because when you have I plus 3 in here, you have to make sure that you are never out of bound. If your I goes all the way to the end of the string, then there's no I plus 1, there's no I plus 3. How do I do it? Just make sure your I plus 3 is less than n. So I is less than n minus 3. And now the code would work. It will work on both situations. Okay. Any questions? So just be careful with this kind of out of bound. Although sometimes you say my code didn't crash, but under other situations. Because in here, if this thing is false, it doesn't even go there. That's why it didn't fail in the first round. But in this second example, if I start to try to put in the code in here, but it failed, and this part would be out of bounds. Okay. Any questions? I think we have one last exercise. I think we had enough today. Let me summarize, and then we'll call it a day today. Okay, so what did we talk about today? The most important thing is the memory model. You have the sense that your code would need the support from the storage, which we have a stack and a heap. What is in the heap? What is in the stack? How the stack frames are constructed and destroyed? What triggers the creation of a stack frame? What triggers the destroy of, like, what triggers the elimination of a stack frame? So those are all the details that you need to understand. And we talk about debugging, right? So Python tutor is good too. And to avoid bad code, like debugging is very frustrating. Okay? Unless you have a lot of experience looking at the piece of code, it just doesn't cut it. So it's very important that you design your code properly. Okay. If you have a bad design, your code are guaranteed to be riddled with bugs, and you have to spend so much time doing debugging. And that's why a lot of times, sometimes you say, I spent 20 hours on this class and still I'm not doing well. What's going on? Most likely it's because you are not starting with the right step. That's probably why. Okay. So I think we will stop here today. If you have questions, I'll be happy to answer them. Other than that, I just want to remind everyone, quiz tomorrow, midterm next week. Okay. So we're done today, everyone. Thank you. Are there any questions?
I'm just wondering if you could go over the sum 6, 7 one, because I was like kind of confused that one.
Okay. So what confused you in here about this code?
I tried to do it, like, I think actually like the thing I got wrong was I misunderstood what the prop was asking. I thought like the 6 and 7 had to be next to each other. But like from
No,
what I saw.
there may be a gap, right? You have to look at these examples, and in this example, you see this 99 is, these two 99s are skipped. So if you understand the question properly, you have questions about this part. I think the core here is the order wouldn't matter. Otherwise, you're gonna add the extra 7 to the sum.
All right, okay.
Yeah, so it's just a flag. When do I add? When don't I add? Use a boolean for that. If I see a 6, I get into the skip mode. If I see a 7 and I was in the skip mode, I'm not in the skip mode anymore. Just make sure you don't add that extra 7, because if this if is after this the skip equals to false, then for the 7 that you see, you're gonna set skip to be false, and then immediately you're gonna add it to result. You can also put this after it, but make it else, so they are mutually exclusive. That's also fine.
All right, okay. I understand now. All right, thank you.
Yep. Any other questions?
So is all of this what we did today? Is this going to be on the quiz tomorrow?
Potentially, everything we cover may appear in the quiz.
Okay.
It's just summer is so crazy, so be prepared. Everything that we tested, that we have covered, may appear in the quiz.
Okay. Thank you.
Any other questions?